Hi students, let's discuss about magnetism. So what is magnetism? So magnetism is a force that can pull or push objects. Magnetism works without direct contact and magnetism is shown by the magnets. So magnetism is a unique property of magnets. Okay, now what are magnets? So magnets are objects that can attract materials like iron, nickel and cobalt. So what are types of magnets? Basically, we have three types of magnets. One is the bar magnet, which is the normal magnet. A small diagram is shown here. Then the second one is the horseshoe magnet or the U magnet. We also have a picture of U magnet here. And the third types are the ring or the disc magnet. They're basically like a thin ring or a disc. Now every magnet has two ends. Basically, these are the north pole and the south poles. Okay, so you can see this north pole and south pole are marked in this bar magnet. It's also marked in the horseshoe magnet and it is also marked in the ring magnet. So what are this north pole and south pole? See, if we take a magnet and if we suspend it with a thread, so this magnet aligns itself with the geographical north pole and the south pole of the earth. So the end which is facing the geographical north of the earth is marked as the north pole and the end which is facing the geographical south pole of the earth is marked as the south pole of the magnet. Okay. Now what is the law of magnetism? The law of magnetism says same poles repel each other. That is, if a north pole of a magnet is facing the north pole of another magnet, both the magnets will repel each other. Similarly, with the south poles. So like poles will repel each other and the opposite pole attract. So when a north pole of a magnet is facing the south pole of another magnet, so they will attract each other. So a magnet creates an invisible magnetic field around it. This is the property of the magnet. Whenever you have a magnet, it will have an invisible magnetic field around it. This is what is called magnetism. Okay. Now see, we are showing this with a diagram. See, in the center you see this magnet. The north pole and the south pole are marked. And there is a magnetic field around it. So we have drawn the magnetic lines which are representing the magnetic field. Now how do we get these magnetic lines? This can be traced by using a compass. So this I will show you in the next video, how to trace the magnetic lines of the magnet through a compass. But now for today we will study the properties of this magnetic field. Okay, the magnetic field around the magnet has magnetic field lines. So these lines which are coming out from the north pole, you see these lines and these curved lines, they are called the magnetic line fields. So this part we have marked it as magnetic line fields. So these are the magnetic lines which are coming out from the magnet, this part. So this basically shows the magnetic field, the invisible magnetic field which is present around the magnet. These lines, okay. So the magnetic field around the magnet has magnetic field lines. So these lines are there, obviously we can see these lines. Okay, magnetic field lines represent the magnetic field around the magnet. So these lines basically represent the magnetic field which is present around the magnet. Okay, the magnetic lines show the direction of the magnetic field and the strength of the magnetic field. We have this arrow marked on these lines. So this arrow gives the direction of the magnetic field. So it is coming out from the North Pole, and it is entering the magnet through the South Pole. And within the magnet, these lines are going from south to north. And see, you can see the loops. So magnetic lines are also forming loops around the magnet. Okay, now let's study about this. We have another diagram. We will talk about the directions of the magnetic field lines. So outside the magnetic field lines go from the North Pole to the South Pole. See, the lines are coming out from the north side, and you can see this loop. This loop is coming and entering to the south part of the south pole of the magnet. Similarly, this side also, it is coming out from the North Pole, and you have this loop lines, and then it is entering the South Pole. So inside the magnet, the magnetic lines go from South Pole to North Pole. So they are traveling from south to north inside the magnet. Okay, the magnetic field lines always form closed loops. So you can see the loops around the magnet. So these are the closed loop which the magnetic lines are forming. Okay, so magnetic field lines are also known as the magnetic line of force. Okay, so what are the properties of the magnetic lines? So the magnetic lines are closed and continuous curves, and they never start at or end in empty space. They always start from the North Pole and they enter the South Pole. Okay, the magnetic lines, they never intersect each other. So what happens if we see the two lines intersecting here? So that means the same magnet is having the magnetic lines moving in two opposite directions. So this is not possible, because we have seen the properties. It starts from North Pole and enters the South Pole. So there can't be any intersection between them. Okay, magnetic field is stronger near the poles where magnetic field lines are crowded. So see, the number of lines entering the South Pole is quite high, and here the number of lines leaving from the North Pole is also very high. So the concentration of magnetic lines are higher at the poles. This shows that the magnetic field is strong at the poles. Now as you go away from the magnetic field becomes weak. So the strength of the magnetic field is inversely proportional to the distance. So the more you move away from the magnet, the weaker the magnetism will get. And the more you come closer to the magnet, you will feel a strong magnetism effect. Okay, the force of attraction will be very high when you come very close to the magnet. Now the direction of the magnetic field at any point is given by the tangent of the magnetic line at that point. So if you suppose if you take this magnetic field line, now if you want to know the direction of this line, you take any point on this line and then you draw a tangent on it. So this tangent will give you the direction of the line, the magnetic field line. Okay, so the magnetic field line, they have both magnitude and direction. So basically a vector quantity. You can clearly see the direction which have been marked by the arrows, and obviously it has got some magnetic strength. So it's a vector quantity. Now let's see how the induced effect of magnetism works. Now what is induced effect of magnetism? The induced effect of magnetism is a process by which a magnetic material like iron, nickel or cobalt becomes magnetized when it is placed near a magnet without touching it. And this magnetism which is produced in the magnetic material is called induced magnetism. So how does this induced magnetism occur? So when a magnetic material like iron or nickel or cobalt is brought near a magnet, so it comes under the influence of the magnetic field. So due to the presence of the magnetic field of this magnet, the magnetic domain of the material gets rearranged. So when this domain gets rearranged, the end near to the magnet develops a opposite pole compared to the magnet, and the other end of the magnetic material develops a same pole as the magnet. Now this has been explained by this diagram. We can say this is, in the first part we have this magnetic material. Magnetic material is far away from the magnet. Okay, now in the second part you see this magnetic material is brought very close to the magnet. Now this comes under the influence of the magnetic field of this magnet. So near the pole we have a strong magnetic field. So now due to this magnetic field, the magnetic domain starts rearranging. Now they are rearranging due to the effect of this magnet here. So due to the effect of this magnet, these domains are rearranging. So initially they were like this. So now due to the effect of this magnetic field, now they are arranging themselves as per the force of this magnetic field is acting on them. So now see, the end which is near to the north pole of the magnet develops a south pole, and the far end of this becomes the north pole, which is same as the pole of the magnet which is close to the magnetic material. And you can see the lines of magnetic force, how they are flowing through this magnet as well as this magnetic material. So due to this induced magnetism, the magnetic material starts acting like a magnet. This is how we can understand about the induced effect. Now this opposite poles are being formed here. See, now due to this opposite poles, a force of attraction is also developed between the magnet and the magnetic material. So these opposite poles will start attracting each other. There is a force of attraction between the north pole and the south pole. The north pole of the magnet and south pole of the magnetic material. So first induction of magnetism takes place and then the force of attraction occurs. So students, we'll close this session here. Hope you have understood how the induced magnetism works. The remaining part we'll do it in the next video. Please like and subscribe. Thank you.